Okay, I'm being recorded. Okay, so I'm PPK, Peter Paul Koch. I run a website called quirksmode.org, and I'm here to talk about viewports. My workshops are usually pretty free-form in the sense that I've prepared about 2 to 2.5 hours of material. I've got plenty of other stuff lying around on my computer that I can talk about. But as I said just now, I'd like to have your input as well. What do you want to know? If you all know everything that there is to know about the touch events, there's not much point in me talking about them. So I'm going to start off with the official Viewport presentation. This will be, I will give the exact same presentation tomorrow, just a short version, so you don't have to come to my session, because I'm just going to repeat what I said today. I've got a tentative number of topics. I'll increase the size a bit. And again, if you have any topics you want to add, please tell me now, later, whenever, and I'll talk about them. There's a few more people coming in, good. Take a seat. And starting off with the presentation is good for me as well, because it gets me into the flow. Okay, so we're going to talk about viewports. What are viewports? What can you do with it? And especially, why are they there? And the secret intention of this presentation is to explain to you why responsive design works. Not how, you already know how it works, but why does it work? What are the underlying principles? Before we get to the viewports themselves, I have to talk a little bit about pixels, because a pixel is not a pixel. That is, there are two kinds of pixels that are important for websites: CSS pixels and device pixels. May sound complicated, it's not, because you actually already know what's going on here, you just don't realize that you do. By far the most important ones for web developers are CSS pixels. What are CSS pixels? They're simply pixels that you use in your CSS. So if you say width 190 pixels, padding left 20 pixels, whatever, those are CSS pixels. And the point of CSS pixels is that they are not real pixels, but an abstract construct that's created specifically for us web developers in order to be able to create a layout and not worry too much about screen resolutions and zooming. Zooming, of course, is tremendously important on mobile, not so much on desktop. I'll get back to zooming later on. And the point of CSS pixels and zooming is that the size of the CSS pixels increases or decreases as the user zooms in or out. I'm going to give you an example of that. This is the example site we will use throughout this presentation. It's a properly responsive site that Stephen Hay created for our Mobilism conference 2 years back. For most of this presentation, we're going to pretend that this site is actually not responsive, because that will teach you a lot about viewports. For now, we're going to take a look at this menu here. Can you all see this, or is it too small? I've tried to adjust the projector a bit, but I'm afraid this is the largest I can get. In any case, we have a menu here with 190 pixels, and that's just a defined width in the CSS. The CSS has a hard-coded width 190 pixels. Now, we are going to zoom in on this page. And as you know, this happens, right? This is just purely normal desktop zoom. The point I'm trying to make here is that this menu, though it's bigger, is still 190 CSS pixels wide. Any JavaScript test you can do will give back a value of 190 pixels. So what happens? All those 190 individual pixels are stretched up because the user is zooming. And that is what's going on all the time with zooming, both on desktop and on mobile. There are differences between the two, I'll get to that later. But this is the basic principle of a CSS pixel. And here you see why it's useful to have an abstract construct, because if we didn't have CSS pixels, you'd have to basically recreate the CSS for different zoom levels, which doesn't make sense at all. So the creators of CSS said, okay, we are going to give you this intermediate layer of CSS pixels. So again, this is unzoomed, zoom 100%, whatever that may mean. And if we zoom in, all the individual CSS pixels are stretched up. That means that this menu, although it's still 190 CSS pixels wide, is now larger. So that's the principle of CSS pixels. And then we have device pixels. What are device pixels? They are simply the physical pixels on your device. Every single computer screen has a limited amount of pixels that's hard baked into the hardware, right? At the moment, a vendor creates a device. It decides how many how many device pixels are going to be on the device, and that number can't change in any way. The best known example is, of course, the iPhone. The old iPhone 3G or something, had 320 device pixels. And then along came the retina screens, which have 640 device pixels. So it's doubled, right? That was the whole idea behind retina. If you have more device pixels on your screen, then your website and your apps will look crisper and smoother. And that was exactly what Apple did. Nowadays, it's becoming fashion to use ever more and more device pixels. I mean, I've got a Samsung Galaxy S4 here, and I think it's got 1920 by 1200 or something like that. In any case, more device pixels is now equated to good, which is true, but I think only up to a point. Because in the end, the human eye can see only so much detail. So in the end, we just won't need any more device pixels on the screen. However, purely for marketing reasons, I think that device vendors will continue to create more and more and more device pixels just because they can. So these are the two kinds of pixels. Here you have a quick schematic. This is at a hypothetical 100% zoom level on a non-retina screen, where one CSS pixel exactly overlaps one device pixel. This is what we were used to in the olden days, right? How many of you did web development before, say, 2007? Quite a few. Okay, so you remember, you got a new bigger monitor, and oh, my site can now go from 800 by 600 to 1024 by 768. That is mostly because there were more device pixels on the screen, right? A bigger screen equates more device pixels. And also because it was, back then it was pretty hard to increase the size of the CSS pixels. You could zoom. I'm going to talk more about zoom later on. But it was not really a use case we thought of, right? Back in the day, we said, okay, this site looks perfect on 1024 by 768. I'm done now. That time is gone and will never return. On came the retina screens, and what happens now is that one CSS pixel overlaps 4 device pixels, 2 by 2. So especially for images, this gives the image a chance of being more subtle, using more subtle gradients and all that kind of stuff, because you just have more pixels. If you use JPEG images especially, they have more information than you need for an old-fashioned screen like this, right? But as soon as you go over to retina screens, then you've got many more device pixels to play around with, which means that your images can have more detail. And that's the whole responsive images discussion. What we want is to send more detailed images to browsers on a retina screen. So here you have, I hope you understand the difference between CSS and device pixels now. Again, it's not really difficult. Intuitively, you are already doing it right. Because what kind of pixels do you normally use? Almost always you are using CSS pixels. Not only in CSS, but also in JavaScript. For instance, if you query the offset width of an element, you get that width in CSS pixels. There's only one single exception to that, and that's screen.width and screen.height. Screen.width and screen.height are a very serious problem, and they are the worst browser incompatibility problem we're going to encounter during this entire session. I'll talk more about them later. Okay, with that said, we can go to the actual viewports. Oh, I'm going too fast. Okay, here we have again our example site. And what Stephen Hay did here was create a container div that spans the entire page and give that container div a padding left of 34%. That's what the design called for, so that's what he did. I want to take a closer look at that 34% now. One important trick you should always remember: if you encounter a percentage anywhere in CSS, always ask yourself, percentage of what? Because that will teach you a lot about how CSS works. So remember, we're going to encounter some more percentages during this presentation. Always ask yourself, percentage of what? So let's ask ourselves, 34% of what? You all intuitively know the answer, 34% of the browser window, right? On desktop, if you have an element that spans the entire page and you give it a padding left of 34%, that means 34% of the browser window. What is interesting is digging a little deeper and figuring out why this is the case, because that will explain to you what a viewport is. So, let's take a closer look. A general CSS rule is that if you have a width or padding in percentages, that width or padding is calculated relative to the width of the parent element. In our case, the container div is in the body. So the 34% here means 34% of the width of the body. Which raises the question, what's the width of the body, right? And that's 100%. Again, a general CSS rule, any block level element in your CSS by default has a width 100%. It takes up as much of the width of the screen as it can. And it has height auto, which means it takes up as little height as it can. Right? That's a general rule in CSS. So the body element has a width of 100%. 100% of what? Of the width of its parent, the HTML element. Right? Because the body is nested in the HTML element, so the 100% are calculated relative to the HTML element. And what's the width of the HTML element? Again, 100%. Because that's the natural width of any block level element. And nowadays, the body and up to a point the HTML element are like normal block level elements. If you, I do this on my own website on quirks.org. The content is in a fairly narrow column. That column is actually the body. I just put a width of, I think, 35 ems in my CSS. I said the body is now 35 ems wide and has a certain margin. So the body is just a purely normal block level element by now. And so is the HTML element, though not entirely. I would advise against doing weird stuff with the HTML element. In any case, in this particular site, the HTML element has a width of 100%. 100% of what? And now we come to the viewport. Because the HTML element is the topmost element in both the JavaScript DOM tree and also in CSS, but there has to be some way of constraining it. CSS in some way has to figure out how much space it has to create its layout. And that's where the concept of the viewport pops up. In the CSS specification, it's called the initial containing block, which basically means this is the block that our CSS layout is going to reside in, and the purpose of that block is to constrain its width. As you might have guessed, on desktop, the viewport or initial containing block is equal to the window, to the browser window. And that is why that 34% you saw just now is 34% of the browser window. Now this makes total sense on desktop, but not on mobile, for reasons we'll go to in a moment. But first, a little bit about zooming. As I said before, when you zoom in, the CSS pixels grow larger, each individual CSS pixel. And the result is that less of them fit on the screen, right? So the viewport becomes smaller. This is an important concept, especially on desktop and to a lesser extent on mobile. So, again, our example site, and the viewport here is about 720 pixels wide. That's because of the way I took this screenshot. There's nothing fundamental about the 720 pixels. We're going to zoom in again. All the CSS pixels grow. Less of them fit on the screen. So the viewport now becomes about 580 pixels wide. And all of the CSS layout is recalculated. That's what makes it expensive to zoom on desktop, because the browser has to go again through the entire CSS layout, recalculate all percentages and all other stuff that's relative to the viewport, well, mostly percentages, display the result on the screen. Right? On desktop it's expensive in terms of processor time and memory management, but that's okay because we've got plenty of both on desktop. Of course on mobile it's completely different. So this is what happens when you zoom on desktop. Now to the mobile side. Before continuing, I'd like you to picture what a mobile browser vendor wants. What Apple wanted back in 2007 when it released the original iPhone. Nokia and BlackBerry ran into the same problems when they created a mobile browser. Android ran into the same problem. Back in 2007, there were hardly any mobile optimized sites yet, because nobody knew you had to do that. Well, there was WAP and that kind of stuff, but real web developers didn't do WAP. I mean, did any of you do WAP? You did? Okay, cool, cool. There's a very few people around that do WAP. WAP was the wireless access protocol, and it was a simplified set of HTML meant especially for mobile phones. And it was usually a completely separate website. But Apple and Nokia and BlackBerry and Google didn't want that. They wanted a real browser on their devices, right? Because that was the whole idea of a smartphone, that you can browse the real web with it, which means that a mobile browser must have a way of showing a desktop optimized site, right? If you go to that website of 1024 by 768, which we web developers thought was perfect back in 2007. When you go there on a mobile browser, it has to show up right. I mean, you can't have a confused jumble of images and text and logos and stuff. It has to at least look right. So what the browser vendors had to do was make sure that a website that's not mobile optimized still renders okay on a mobile browser. It will never be perfect. Right? For a perfect user experience on a mobile device, you need a mobile optimized site. But still, I mean, plenty of you will regularly encounter websites on your mobile phone that are not mobile optimized in any way. So how do mobile browser vendors handle that? The problem is that if they would literally copy the desktop principles to mobile, it would go wrong, because the mobile screen is just smaller than a desktop screen. Simple. So many sites would be squeezed to death, and that's exactly what the mobile browser vendors did not want to happen. So, we again, oh, I gave away the point. The example site, 34%, 190 pixels on the desktop. Now we're going to a mobile view, and we are going to pretend that the mobile phone does exactly the same as the desktop. And you get this. Right? Here the viewport is constrained to 342 pixels, if I'm correct. That would mean that the whole site doesn't make sense anymore. Again, a desktop optimized website. There's nothing mobile about this site, right? So mobile browser vendors didn't want this to happen because, you know, the user experience is not very rich. So what did they do? They changed the rules. They said, okay, we still need a viewport, right? Because we need some initial containing block for the CSS. We need to tell the CSS, okay, you can take so much space. But that viewport is going to be in the range of 768 to 1024 pixels wide, with the most common value being 980 iPhone. So if mobile browsers encounter a desktop website, they say, okay, the viewport is going to be somewhere in this range. which is usually enough to show a desktop optimized website decently. Not great, absolutely not great. I mean, we're still in the early stages of mobile development here. Nobody had any clue that there were tricks like responsive design that could help us create better mobile experiences. But this was something that mobile browser vendors absolutely had to do. And this is what I call the layout viewport. And after 3 mobile viewports, it's by far the most important one. Again, because it tells your CSS, okay, you have so much space. And the fundamental trick of responsive design is the art of overriding the default layout viewport. Right? Because what we eventually want to do is say, okay, my site should not be 768 pixels wide, but 320. But you have to give a special command for that, the meta viewport tag, which I'll come to in a moment. So again, this is the core of what's going on with responsive design and mobile browsers. The viewport had to be larger than the browser screen, because otherwise desktop optimized sites would look horrible on a mobile phone. But on the other hand, they had to give us, web developers, an opportunity to change that default layout viewport. So this is the layout viewport, right? This site is clearly far too wide for a mobile phone, but it's the best a mobile browser can do with a desktop optimized website. However, the layout viewport is now much wider than the screen. And occasionally we do need to know how wide the screen is. For instance, with position fixed. Position fixed is relative to what the user is seeing. And the user, wait a minute, where is it? The user doesn't see all of this, right? The user only sees this part of the site. That's how mobile works. And then he pans and zooms and does whatever is necessary. But we still need a way of figuring out how much the user is seeing, which means we need a separate viewport for that. And that's called the visual viewport. The visual viewport is what you are currently seeing on the device screen. By the way, the terms layout viewport and visual viewport originally come from Opera. Back 3 years ago when I first defined this, I had to have words to talk about these viewports. And I had a conversation with Anna van Kasteren, who still worked at Opera then. And he said, yeah, internally we call this the layout viewport and the visual viewport. And I said, okay, yeah, that will work for me. So now these are more or less the official names. I mean, I visited a browser vendor recently and they used my terms, which was kind of cool. You know, I invent something and they say, yeah, hey, that works. We're going to use it internally. So the layout viewport is for constraining your CSS. The visual viewport is for defining what the user is actually currently seeing. So this is the visual viewport, right? Again, this may sound complicated, but it's actually not. Because you will rarely do anything with the visual viewport. I mean, it's really only position fixed and a few other CSS declarations that are where the visual viewport is really necessary. 90% of your time you will be working with the layout viewport that constrains your CSS. Okay, can we read this out in JavaScript? Yes, we can. The layout viewport, the dimensions of the layout viewport, the width and the height, can be found in document element client width and document element client height. And this works in just about all browsers with the exception of proxy browsers. I tested this. Oh, by the way, how many of you know what a proxy browser is? One. That's not a lot. I will have to talk about proxy browsers then. Okay, we're going off track now. A normal browser, you request a page and the normal browser gets the HTML, CSS, JavaScript, images, videos, whatever. It all comes to the browser, it's interpreted and rendered there, and then the result is shown on the screen, right? That's how a normal browser works. A proxy browser does something quite different. The most important proxy browser is Opera Mini. Not Opera Mobile, but Opera Mini. Those are two distinct browsers. And what Opera Mini does is, as soon as you request a website, it sends off the URL not to the web server, but to a special Opera Mini server. That Opera Mini server subsequently sends out the request to the real web server. The Opera Mini server catches the HTML, CSS, JavaScript, images, videos, etc. And the Opera Mini server creates a rendered page for you and sends off that rendered page in a kind of a PDF-like, bitmap-like format to the Opera Mini client that's on your phone. Now, why is this useful? It's useful because it saves you money in two ways. First of all, because the Opera Mini client is light. Basically, the Opera Mini client only has to be able to send off a request to the Opera Mini server, show a kind of PDF-like image, have a location bar, and be able to register clicks and such on the page, right? You still have to be able to click on links. That means that the Opera Mini client is very light, which means that it can run on really old, crappy devices. If you are a consumer in the developing world, say in India, Nigeria, China, whatever, you don't have all that much money, you buy a really cheap phone. That really cheap phone just doesn't have the hardware to contain a real browser. But it can contain a proxy browser client. So that means that proxy browsers are mostly used by people with older devices. However, there's a second advantage to this. Because you only get back a PDF-like rendered page, it means that your data is very low. You don't have to use as much data for the PDF as you would for a regular site with the HTML, the CSS, the JavaScript, the images, etc. Which means that you don't spend so much on bandwidth. I've got Opera Mini installed on all my phones, especially for a situation like this. I'm abroad, my roaming is just about dead, but not quite yet. You know, I think I've got 10% of my roaming limit left, and I want to keep that 10% if there are any emergencies. If there's an emergency, I would like to use it cheaply, which basically means use Opera Mini. So Opera Mini can be used on low-spec devices, and it saves you a lot of money for bandwidth. Opera claims that it saves about 90%, 90 that is, of your bandwidth. I've never tested that, but I kind of believe them. And that makes proxy browsers very interesting for people, especially in developing nations. I'm following the browser statistics of a few countries around the world, and I'm seeing that especially in Nigeria and India, these proxy browsers, and then especially Opera Mini, have a market share of well over 50% because they are cheap. So if you are doing anything that should be shown outside the US in developing nations, make sure that it works on a proxy browser. There's a disadvantage to all of this. We've not treated the advantages, but the disadvantage is that there's no client-side interactivity. Because if you had to interpret JavaScript on the client, it would mean that the client would grow fat and cheap phones wouldn't be able to run it. So Opera Mini does support JavaScript, but it goes back to the server to ask for instructions. So you have a page with some Ajax in it or something, you know, you click a link and you get more data. If you click the link in Opera Mini, it goes back to the server and asks for instructions. And the server then executes the JavaScript, fetches the new data, and creates a new rendered page that it sends on to the client. What I want you to understand is that this is a trade-off. It's not a bug, it's a feature. Basically, executing JavaScript costs money because you need a better device for that. And some people just can't afford it, other people don't want to, and they say, okay, I'll offload it to the server. So the user experience on a proxy browser is always less than on a full browser, by definition, but it's a deliberate choice by the consumer. That's very important to keep in mind. Opera Mini by default is installed on not all that many phones, but especially in Russia and in the countries of the the Commonwealth, the former Soviet Union, nearly everybody downloads Opera Mini because it saves you a lot of money and it has become something of a hype, right? Friends say to each other, oh, you can save money by downloading this to your phone, and then you can surf all you want, and it will cost you only 10% of the money. And that's kind of cool for the people out there. So the trade-off between less money and less JavaScript is a deliberate choice by the consumer. It's not a disabled browser or anything. It's very important for consumers in certain countries. So if you do any work on websites that should render fine in the developing world, you must test on Opera Mini and also on the other proxy browsers. I'm going to get back to browsers later on. So, one of the problems proxy browsers have is that they have no clue how wide the device actually is. I think that's strange. I think they could actually know, but they don't. Which means that this does not work in proxy browsers. Because they say, I'm not sure how wide all of this is, let's make it 1,000 pixels. Which usually doesn't make sense. So, except in the proxy browsers, however, document element client width, document element client height always gives you the dimensions of the layout viewport, which is the viewport that constrains your CSS. We're going back on track now into the presentation. If you have more questions about proxy browsers, I'll answer them later. So that's a layout viewport. Visual viewport, window.inner width and window.inner height. Slightly less well supported, mostly because Android WebKit 2, the old Android default browser for the old crappy Android devices, doesn't support it. Opera Mini, here we get it, right, the proxy browser. It has no clue how wide the screen is, so it can't tell you. And it says, yeah, you know, I think it's about 1,000 pixels, which never makes any sense on a mobile phone. Oh yeah, and UC8. You've heard of the UC browser? No, it's the most important browser in China. If your website has to be viewed in China, you must make sure that it works on the UC browser. Now, UC8 is a weird browser. UC9 is a lot better. So I just include UC8 for fun here. UC also has a proxy browser, by the way, called UC Mini. I'll get back to that. So, what we have seen is that the desktop viewport, which serves both to constrain your CSS and to define what the user is currently seeing, that viewport has been split into two on mobile. The layout viewport for constraining your CSS and the visual viewport for defining what the user is currently seeing. However, there's a third mobile viewport, and that's what I call the ideal viewport. This term, by the way, is wholly my own invention. I have consulted nobody. I thought, okay, this is the perfect name. Some people say, yeah, maybe it's not really a viewport, and I kind of agree with them, but I don't know how to explain it better right now. I mean, it took me 3 years to get to the point where I could explain the viewport in 40 minutes, as I will do at the conference tomorrow. So I call it a viewport. What exactly is the ideal viewport? In order to understand that, we have to have get a closer look at what the browser actually does to a desktop website. What I've shown you so far is not really what's going on. This is more like how a mobile browser shows a desktop optimized website. It zooms out as much as possible. And that's kind of the least bad method of showing the website, because the text is unreadable. You can't read it at all, but you can get a kind of a general overview of the website and decide where to zoom in. You know, main text, navigation, news items, speakers, whatever, you can choose. And that's kind of okay. It's not brilliant. I mean, again, a desktop website is just fundamentally unsuited to be shown on a mobile device, but still, browser vendors have to do something about it, and this is the approach they chose, and I kind of agree with it. What we want, of course, is to adjust the layout viewport to the width of the device, right? Because there's an optimum width for the layout viewport for each separate device. And that's why the ideal viewport comes in. Because the ideal viewport basically defines what the perfect layout viewport for the device would be. Browser vendors want to make sure that consumers don't have to zoom and pan, but just see the correct website straight away. Basically, the ideal viewport is just a width and a height that's buried somewhere deep in the browser and that you can call forth if you use the correct code. And of course, the point of responsive design is setting the width and height of the layout viewport that constrains your CSS to the values of the ideal viewport, because then your website will show up perfectly on the device it's on. And you get this. This is a proper responsive design, right? But in order to get here, we have to do two things. First of all, we have to constrain the layout viewport to the size of the ideal viewport, so that you get the perfect UX for the device. And secondly, then we have to use media queries in order to figure out what the device width actually is now. Excuse me, the layout viewport width actually is right now. And, you know, switch from 2-column to 1-column CSS and do more stuff. So that's where we want to go, right? That's responsive design. I'm using the BlackBerry Z10 Z10 here as an example device, partly to remind you that there's more than just iPhone and Android, right? Who here regularly tests on a phone that's neither iPhone nor Android? There's more than just iPhone and Android. Not much more nowadays. That's my mic. There's not much more nowadays, but BlackBerry and Windows Phone are still around. And especially on BlackBerry, you will find that the browser is pretty much decent. I mean, BlackBerry has a good browser team, they know what they're doing, and in general, your website will work pretty much okay on a BlackBerry. Windows Phone, IE, is another story. I'll get back to that. The other reason I chose the BlackBerry Z10 is because it has an unusual ideal viewport of 342 by 570. On the iPhone, of course, you already know the dimensions. It's 320 by 480 on the older models and 320 by 568 on the newer models, right? That's the ideal viewport for the iPhone. However, BlackBerry does something different. The point I want to make here is that this is not wrong. There are no wrong dimensions for the ideal viewport. I tested a lot of browsers. I tested about 50 browsers on about 35 devices. And in all cases, I found an ideal viewport that kind of made sense for the device it was on. You could argue a little bit, you could argue 10, 20, 50 pixels, but not much more than that. So my point here is that the 342 by 570 may sound weird to you, but it's not wrong. They are what they need to be for the device. So this just serves as a reminder that there's more than just a 320 for the iPhone. That's the point I want to make. Let's go to the iPhone for a moment, because we will see an additional advantage of the ideal viewport. We have the old iPhone, the 3G, and it had 320 device pixels, and the ideal viewport is also 320 pixels. And that's, of course, not a coincidence. Then Apple switched to retina screens, which made the screen be 640 device pixels, but the ideal viewport remained at 320. There were two reasons for this. First of all, 320 is genuinely the best width of viewing a website on an iPhone. And secondly, if they would change the ideal viewport, a lot of sites would break. Right? Because by the time the retina screen came around, a lot of web developers had already created iPhone optimized websites, and Apple didn't want to break those. So what we're seeing here is that the ideal viewport is once again a kind of an abstraction layer for us web developers. We don't really care what kind of iPhone somebody uses, because we know the ideal viewport will always be 320 pixels wide. The only way in which we do care, of course, is retina versus non-retina for responsive images, which we'll come to later. But the pure layout of your site does not change from an older to a newer iPhone. It remains the same. This is especially important on Android, because there are literally hundreds of different Android devices, mostly with a decent browser at least, and your website could work in it. The problem, of course, is that there are many, many screen sizes around. I haven't even attempted to count them, but there's a lot of them. However, you will find that the ideal viewport on Android browsers is generally either 320, 360 or 400 pixels. So if you make sure that your website works in 320, 360 and 400, you have covered about 80 to 90% of the Android devices out there. Again, the ideal viewport serves as a kind of an abstraction layer on top of the device. It doesn't really matter to you how wide the actual screen is, because you've got the ideal viewport to take care of that. You just make sure that your website works on 320, 360 and 400. Yeah.
Why are we only talking about the width so far?
We are talking about the width so far. Heights, in general, heights are slightly less important. There are use cases for heights, certainly, but I tend to talk about widths because the width is really, really important. You have to constrain the width of your layout viewport in order to create a website design that makes sense on mobile. Height is useful in some cases. I can think of making sure that something is above the fold or something like that. But first of all, it's just less important than width. And secondly, you can't really set the height of the viewport. Later on, we'll see the meta viewport tag. I mean, I'm slowly working up towards the meta viewport tag, and I'll give you a hint. If you say width equals device width, you set the layout viewport to the ideal viewport. That's what you're doing then. In theory, there's also a height for the meta viewport tag, but it doesn't work anywhere, not even on Safari. So you cannot set the height of a site. You can only set the width.
Okay. What happens in the landscape?
I will get back to that. But first of all, can we read out the ideal viewport sizes in JavaScript? Kind of. Unfortunately, it's unreliable. This is the screen.width and screen.height problem that I mentioned earlier. Screen.width and screen.height just used to mean the number of device pixels on your screen, right? But it doesn't anymore. The problem is that some browsers nowadays define it as the dimensions of the ideal viewport, while other browsers still use the old definition of device pixels. And you don't know beforehand what you're going to get. So if you read out screen width and screen height, you may get the right information, you may get the wrong information. You just don't know, which makes it unreliable. Incidentally, this very fact also means that all the nice analytics packages that gives you resolutions of mobile devices that visit your sites are unreliable. Because they all use screen.width and screen.height, but you don't know which of the two definitions they're using. So if you're seeing weird Android devices of like 1200 by 800 or something, that is because the browser still uses the old definition and not the new one. Android WebKit, which is the older default browser on Android, uses the old definition, while Safari and Chrome use the new definition. And the full compatibility is on my site, by the way. I mean, every single thing here is documented on my site. I tested it in 50 browsers. You can look it up there. So this is a very serious problem, and I also think it's the most serious browser compatibility problem we're going to encounter during this workshop. At the moment, there's no solution. I expect all browsers to start to use the dimensions of the ideal viewport, but the main problem is Android WebKit, the old Android default browser. It's not under development anymore, so it will never change. So it will also always use the second definition. And there are other browsers that do the same. I have to look up which one. I don't know them by heart. But screen.width and screen.height are fundamentally unreliable, and you should never ever use them in your sites. Okay, now we're getting around to the meta viewport. I already gave away the clue, but you know, who cares? So, we want a responsive design. And the first step towards a responsive design is constraining the layout viewport to the ideal viewport size so that your website will have the perfect width for the device it runs on. Again, you don't know how much that width will be. It will often be 320, but by no means always. It can be 360 or 400 on Android. We saw the 342 for the BlackBerry. Windows phones have even weirder values. I encountered a 364 there. We'll get back to that. But you don't care. all browser vendors choose an ideal viewport that's ideal for the device the browser runs on. You can count on that. You just have to set it to that ideal viewport width, and your site will look good on that specific browser, on that specific device. Now, how do you do that? This is how, right? This is the point of the meta viewport tag. The meta viewport tag, and especially width equals device width, sets the layout viewport dimensions to the visual viewport, to the ideal viewport dimensions. So that's what you do when you add this tag to your. I mean, you've all seen this tag, right? Who has never heard of the meta viewport yet? Cool. Okay. So I hope that you now understand what you are doing when you're using it. Let's take one step back and try to define what's going on here. So by default, if you do not use the meta viewport tag, your layout viewport will be between 768 and 1024 pixels wide because of desktop optimized sites that have to be shown decently on a mobile phone, right? 980 pixels is the most common value. If you set the meta viewport tag, and especially its width declaration, then you set the width of the layout viewport to a value of your choice. This value may be a pixel value. You can say width equals 400, if that makes sense for your site. So if you just say width equals 400, the layout viewport will become 400 pixels wide in all browsers. But usually 95+% of the time, we use the device width keyword to set it to the ideal viewport width. This is what the meta viewport tag does. I said it before, in theory there's a height here. In practice it does not work anywhere at all, not even in Safari, even though it's in the Apple documentation. I have no clue why they included something that doesn't work in the documentation. But hey, that's browser documentation for you, right? I mean, if I look back on my career of 15 years as a browser tester, I found that there's only one single browser vendor that consistently creates decent documentation, and that's Microsoft. MSDN is hell to use. I mean, you can never find what you're looking for. You have to search for endless and endless days. But once you find it, the information you want is actually there. Chrome does not have any documentation whatsoever. The Safari documentation is rather rudimentary. They're trying to do something, but it doesn't always reflect reality, such as with the height keyword here. Mozilla is kind of okay nowadays. I remember the days back 15 years ago when the Mozilla documentation was more like a wish list for the browser. We eventually want to support this, so we put it in our documentation. Nowadays it's better. MDN is a good resource. But I don't know how I got to this. Anyway, browser documentation. So this is how the meta viewport works. There are more things you can do here, and we're going to go to that now. Because I'm kind of assuming this does not come as a surprise to you, but I'm hoping that the next line of code will come as a surprise to you, because there's a second way of doing exactly the same. And that's this. Initial scale equals 1. In theory, scale is Apple speak for zoom. I don't know why they call it scale. Normal people call it zoom. The 1 here means 100%. Do you remember the question to ask? 100% of what? Anybody dare to guess? I say zoom 100%. 100% of what?
Device width.
Excuse me?
Device width.
No. It turns out it's 100% of the ideal viewport. Again, on all browsers. I'm not totally sure why they did this. When I started these tests, I expected it to be relative to the layout viewport, even if you have the default viewport of 980, or you explicitly set the viewport to 600. I kind of expected initial scale to be relative to that. It's not. It's always relative to the ideal viewport. So this is what initial scale does in theory. It sets the initial zoom level for the site relative to the ideal viewport. However, it does a second thing, and that is, again, setting the layout viewport to the dimensions of the ideal viewport, just like width equals device width does. Don't ask me why, I don't understand it. But I can assure you that this works in all browsers. It gets even weirder when we use a different value. Here we say 200%, and remember that 200% zoom means that the CSS pixels stretch up and less of them fit into the viewport, into the visual viewport in this case. I have to talk, remind me to talk about mobile zooming, because this presentation doesn't really go into mobile zooming, but you need to know. In any case, so 200%, which in practice on the iPhone means that you don't see 320 pixels in the screen, but 160. Because all CSS pixels grow to twice their usual size, so only 160 of them fit on the screen, right? There's an inverse relationship between zoom level and the dimensions of the visual viewport, of the stuff you see on the screen right now. Because zooming to 100% means that only half as many pixels fit in the CSS, in the visual viewport. However, this also sets, oh, wait a minute. This also sets the layout viewport on the iPhone not to 320 but to 160. And it does so in most other browsers, the most important exceptions being Android WebKit, again the old Android default browsers, and IE, though IE 11 has made some steps in the right direction. So if you really want to, you can set the width of your layout viewport to half of, or 1/3 or double the ideal viewport. I don't know why you want to do this. I do not recommend that you do it, but technically it's possible and it's weird. I mean, I totally do not understand what's going on here, but I can absolutely guarantee you that this works with the exception of Android WebKit and IE for values other than 1. So we will have a second way of doing the same. Now comes the fun part, and I'm going to get a glass of water before we get to the fun part. The fun part is the reason I do browser compatibility research. Once I've figured out how something works, I try to mess up the browsers. I try to give them weird instructions and see how they react. So what I did as a test was this. Width equals 400, initial scale equals 1. What I'm doing now is giving the browser conflicting instructions. On the one hand, I tell it to set the layout viewport to 400 pixels. On the other hand, I tell it to set it to the ideal viewport and also set the zoom level. But ideal viewport is what the point is here. What do browsers do now? When I started this test, I kind of figured that browsers would be all over the place and would do weird stuff, and I had to have a really complicated row of compatibility information with 3 or 4 different things happening in the various browsers. It turns out that that's not the case. It turns out that all browsers do exactly the same in this case. They take the highest value. The 400 is fixed value. Initial scale equals 1 basically means the ideal viewport width. And they take the highest value of the 2. And now comes the fun part. When you switch orientation, they again calculate the highest value. So on the iPhone, the old iPhone 320 by 480. In portrait mode, initial scale gives 320 pixels. Width equals 400 gives 400 pixels. The browser uses the highest value, which means 400 pixels layout viewport in portrait mode. Then we switch to landscape mode, where the width is still 400, but the initial scale now gives 480. And it switches to 480. 400, 480. And again, this works in all other browsers in the same way. So what we have found here, basically, is a way of setting a minimum width to layout viewport. If you use this bit of code, your layout viewport will always be at least 400 pixels, or larger if the ideal viewport calls for that. Now, I discovered this in November, and all the time since then I've been wondering, is this useful in practice? And I don't know. That's a problem of fundamental research. Sometimes you encounter something that's quite interesting from a theoretical perspective, but I have no clue why you would want to use this in practice. If any of you thinks of a good way of using this thing, please let me know, because I'm looking for practical examples. I mean, I will continue looking for practical examples for the entire year. I'm going to give this presentation and this workshop again and again. If I haven't found anything by the end of this year, I conclude this is theoretically interesting but practically useless. Does anyone have any idea how we could use this? Any of your websites would be helped by setting a minimum width for the layout viewport? Think about it. If you think of something, please do let me know. Okay, Safari. Safari has an annoying, not quite bug, but certainly an incompatibility. That is, if you use width equals device width, in both portrait and landscape, the width of your layout viewport will always be 320 on an iPhone and 768 on the iPad, right? I kind of assume you've noticed that. And sometimes that's what you want, and at other times it's not what you want, because you want the layout to be responsive. So, how do we solve this? It's extremely simple. You just use this. Now it's 320, 480. Why the difference? I have no clue, but it works like this. And all other browsers do the same, so that's cool, except for IE10, which is exactly the opposite bug. In IE10, if you use this, it's 320, 320. If you use a width equals device width, it's 320, 480. Don't ask me why. But the IE team confirmed to me that this is in fact a bug, and I think it's solved in IE11. Yes, it's solved in IE11. But still, IE10 is still around, so you have to cater for it. How do we solve this? Fortunately, the solution is extremely simple. It's this. Use both. So this is the general advice I give to everybody. Use this meta viewport and all your browser incompatibilities will go away. Width equals device width, comma, initial scale equals 1. That's the way to do it. Because initial scale works perfectly in Safari, device width works perfectly in IE10, both work perfectly in all other browsers, and you get the desired result. So this is the perfect meta viewport. However, there's one thing that's rather weird about the meta viewport, and I don't mean in its implementation, but in its structure. What we're doing here is using an HTML tag to give instructions to the CSS layer, right? In the end, what we're doing here is setting the layout viewport in the CSS, which is a task that's best left to CSS itself, which is why originally Opera proposed this syntax for in the CSS. Add viewport, width equals device width, zoom 1, etc., etc. Opera supported this in the old Presto rendering engine, but Opera has meanwhile switched to the Blink rendering engine, right? You know this, right? Is there anyone from whom this is news? Good. So they supported it in the old Presto rendering engine, but not in the new Blink, though I think I heard a rumor that they're busy implementing it in Blink, so it may come to Opera and Chrome and the other Blink-based browsers. Right now, only IE uses it. And actually, it's pretty important in IE. This is how it works. It's prefixed right now, right? Because it's still under construction and so on. But this works in IE. And the interesting part of this is that it gives you the true ideal viewport of the device. I've got, does anybody else have a Windows phone? Okay. You should test this because I myself, so far I tested it only on the Lumia 820, which I carry with me. I heard the whole story is totally new to me. I heard this only last week when I visited Microsoft. So I still have to do the final tests. So what you're seeing here is untested conclusions. But it does work on the Lumia 820. Yeah, well, you can't see it very well, but the Lumia 820 is slightly wider than the iPhone. So from a purely UX standpoint, it should have a slightly wider ideal viewport. However, if you use the meta viewport tag, IE always sets the viewport to 320. Why? Because it wants to imitate the iPhone. If you, however, use this, it uses the ideal viewport that's really, really suited to your device, and in this particular case, it's 364. Again, this sounds weird, but it actually makes sense on the device. Other Windows phones will have other ideal viewports, but again, you as a web developer don't care about that. You just want to use media queries later on to read out the viewport size and do something interesting to your CSS. So, what the IE team said is, okay, most web developers aren't paying attention. They don't test in Windows phones. Why not? Because there are not all that many Windows phones around. IE has a global mobile browser market share of about 2%. So they are just going to focus on the iPhone. So with the meta viewport tag, we just set it to 320 and it will be kind of safe. But if you know what you're doing, you can add the MS viewport and set it to the true ideal viewport. And they told me, but I haven't tested yet, that the add viewport overrides the tag. When I get back home next week, I will test this on all my Windows phones, make sure that it actually works. We'll probably also write a blog post about this, because this whole story was not at all clear to me until the IE team actually explained it to me. But this is the way of making Windows phones, and only Windows phones, i.e., to take their true ideal viewport. I still have to test it, but I kind of assume that 364 width we get here is better than 320, because the device is just slightly wider than the iPhone. So, the absolutely totally perfect viewport is this. You use this in your CSS, this in your HTML, this will override this in IE, all other browsers will only look at the meta viewport tag, and you will be absolutely fine. Yes?
The MS viewport has to be the first thing in your CSS file?
I think so, but I haven't tested it
From
yet.
my experience, it has
Oh, okay, cool, okay.
And it also means that your responsive designs will honor the snap mode in Windows in its Metro view.
Interesting. I didn't know it was automatic.
I can chat with you about that.
Okay, yeah, no, that's interesting. So far, I haven't tested IE really well yet, and I especially haven't gone into the Microsoft-specific stuff. But I'm going to change that now, because when we talk later about touch events, we will see that Microsoft uses not touch but pointer events, but they actually have a good reason for that. And here as well, they may actually have a good reason. So the snap points have a default value or something?
Yeah, I think it's 320.
320,
but you
okay.
can change, I think there are 2 widths now in the 8.1 release. I just
Okay.
don't know for sure.
Okay, so Microsoft snap points are kind of, you scroll sideways, and you want that scroll to end by the next pane scrolling into view and staying there. So if you scroll partly sideways, the Microsoft snap points kind of take over and make sure that it scrolls all the way. This is hard to explain, so maybe we will show it later on. You have a Windows?
Well, when I say snap mode, I'm talking about when you're in Windows, in Metro, you can be playing your Windows accordion, and then you can slide in another process, another application.
Oh, you mean,
so
yeah.
When I say snap mode,
Yeah,
I mean
that's...
most of your screen is one application, and then the 320 pixels over here.
Yeah.
Or some.
Yeah, you can divide the screen on Windows 8 tablets. Yes, and then yes. Okay, sorry, I get it now. I already knew this, but I'd forgotten. We go. No, wait a minute. We stay here. Again, I haven't tested IE as well as I should have. This works in IE on a Windows phone, but not on a tablet or desktop. It does not work on the Microsoft Surface or any other Windows 8 tablet. However, this does work. I'm not totally sure why they made that decision, but it will probably have something to do with web developer expectations. In general, Windows 8 devices have a total width of about 1366 pixels. At least that's what the Surface has. And that is enough to show a desktop website decently. So they kind of don't really need this. But they still implemented this on tablets. So this even perfecter viewport also gives you Windows 8 tablets, also supports Windows 8 tablets. Okay, so what we have seen now is ways of setting the width of the layout viewport. Again, the layout viewport is the viewport that constrains your CSS, that tells you HTML has a width of, the HTML element has a width of 100%, how much is that? And you can change that on mobile and tablet browsers. Once you've done that, once you've set it to the ideal viewport, which you want to do in most of the cases, you want to read out exactly what that ideal viewport is and adjust your CSS, right? Because it should look different on an iPhone and an iPad, or on an Android phone and a Windows tablet, whatever. You do that with media queries. I'm kind of assuming you've all seen a media query before, right? If the width is 600 pixels or less, then implement this CSS. And of course, the question is, what does width mean here? There are two important media queries for width, and those are width and device width. And width is the correct one. If you use device width in your media queries, I'm terribly sorry to inform you, you are doing it wrong. And I will explain why right now. Because device width tells you how wide the device is. Now on desktop that does not make any sense at all. I am not interested in the width of my screen, I'm interested in the width of my browser window, right? That's what I want to know in order to create a proper responsive design. On mobile, at first sight, it seems that device width is interesting because it gives you the width of the screen. However, it turns out that that's not really the case, because in all 50 browsers I tested, the device width media query is always exactly equal to screen.width, and device height is equal to screen.height. The problem is, as we saw before, that screen width and screen.height can have two different meanings, the ideal viewport or the number of device pixels. And you don't know in advance which one you are going to get. The problem here is that what you want to know is the ideal viewport width, and it works like that in Safari. So if you test only on the iPhone, and you use device width, it works. But if you test on an Android device with the old Android default browser, you will find that it does not work because it follows the other definition. So that's why device width is not the way to go. If you use this anywhere in your sites, please change it to width. Because width gives us the width of the layout viewport, both on desktop and on mobile, and that's exactly what we want to know. On desktop, we want to know how wide is the browser screen, in other words, how wide is the viewport, and on mobile, we want to know how wide the layout viewport is. Because once we've set it to the ideal viewport size with the meta viewport tag, we still need to read out the actual current size and adjust our CSS to that. And that's what width media query does. It works in all browsers, and I mean literally all browsers. And once you have implemented both the meta viewport tag and with media queries, you get a proper responsive design, and that's what you want. Okay, so to briefly recap responsive design, you set the layout viewport width to the ideal viewport width. You may choose another value, a pixel value, if you want, but there's rarely any need for that. But technically it's possible. Then you use the width media query to figure out how wide this actually is, and you adjust your CSS. I hope that this presentation so far has explained to you why responsive design works, because that's my purpose with this series of presentations and workshops. Everybody knows how to do it, but too few people know why. You need to know a little bit about the underlying theory here. Oh yeah, one more thing. Always use the min or the max prefix. You are not interested in specific values. You are not interested in width 320 pics. Of course, it will work on the iPhone. It will work on Internet Explorer because the IE team made sure that it does work. It will work on some Androids, but it will fail on other Androids, and for instance on the BlackBerry browser with its ideal viewport of 342. So what you, the way to define a breakpoint is to say the following styles are valid for all widths that are larger than or smaller than X. That's important. I mean, it's a general principle, I think, not only of media queries, but of web design as a whole, that you should just create breakpoints or whatever in a device-neutral way. I mean, what Stephen Hay always says is you start with the design, and then you start to either stretch it out or make it smaller. And once it starts to look really, really ugly, it's time for a new breakpoint. And that breakpoint may be at an odd value. It may be at 350. If your design needs a breakpoint at 350 pixels, put it in there, because that's what breakpoints are for. They are not to target specific devices. They are to make sure that your website design will always look optimal in the specific viewport with the devices currently using. So don't hesitate to set breakpoints to odd values. Okay, so this is responsive design. And I'd like to treat a few more things about responsive design, because what we would like to have as web developers is not only to react to the ideal viewport, but also to react to the actual physical width of the device. Right? It would be useful, for instance, to say, okay, our navigation items should always be at least 25 millimeters wide. 25 real-life millimeters, so that the user can always click on them, no matter how much he zooms in or out. The problem is that that is impossible. And the reason for that is the specific way that CSS units are set up. You would expect that millimeters, inches, or centimeters would correspond to the real world. They do not. Because 25 millimeter in CSS means 94.488 pixels. Why is that? Because centimeters, millimeters, and inches are fake units. And 1 inch in CSS is defined as 96 pixels in all browsers. Again, I tested this in 50 browsers. In every single one of them, if you create a block of 1 inch, it's exactly the same width as a block of 96 pixels. And if you zoom in, CSS pixels become larger, right? So your inch will also become larger. You may have this inch or that inch, depending on the zoom level of the device at this moment. That is the reason that these so-called physical CSS units are not physical at all. Until last week I thought, okay, at least they work in print style sheets, but then somebody in the audience stood up and said, no, they don't. Even in print style sheets, they don't really work all that well. Although I found that, especially in older IE versions, they do kind of work. I occasionally create my own board games, and I sometimes need to print out cards. And I found that if you print them out in IE, you get roughly the dimensions you specified, but all the other browsers are complete rubbish. Especially Chrome, apparently. I haven't tested this personally, this is second-hand information, but it seems that Chrome and print style sheet do not go well together. In any case, let's forget about print style sheets. Let's instead talk about CSS units. 1 inch is defined as 96 pixels, so it has nothing to do with the real world, and these are the actual unit definitions in CSS. So 1 inch is 96 CSS pixels and 2.54 centimeters, and 1 centimeter is 10 millimeters. 1 inch is defined as 72 points, and 1 pica is defined as 12 points. Again, I tested this in 50 browsers. I just created a test page with a lot of blocks that should be equal in width when these definitions are correct, and they turned out to be correct in all browsers. This is how CSS units work. So you cannot find out anything about the actual physical device by using CSS units. Now, I used to think that all this was a pretty bad idea, and that it would be kind of useful if 25 millimeters meant 25 real-world millimeters, but I changed my mind. Because if you did that, it would mean that every time you zoom in, the browser would have to recalculate its entire layout. because I would have to see, okay, one CSS pixel is now roughly equal to 0.54 millimeters, whatever. So I have to make sure that these buttons are still 25 millimeters at least. So I have to resize them, and the rest of the layout may change as well, etc., etc. That all takes way too much processor time and memory and battery life. A consistent thing that you will see in mobile browsers especially is that they do everything in order to preserve battery life. They don't want to reflow their pages too often. Because that reminds me, I haven't talked about, I've talked about desktop zooming at the start of the presentation, but I don't really have slides about mobile zooming, but it's still important. On desktop, the viewport changes when you zoom, right? Because the CSS pixels become larger and less of them fit in the screen. On mobile, that is not the case. On mobile, the layout viewport stays the same no matter how much you zoom. Right? So if you zoom in, the visual viewport, the part of the site you're currently seeing, that changes, because it's still the case that less CSS pixels fit in the screen. So you see less of the site. Of course, that's the whole point of zooming in. But the layout viewport stays the same. So there is no reflow on mobile. The browser doesn't have to recalculate the entire CSS, and that's deliberate because it would just take too much processor time, too much battery life. The same with CSS millimeters. It would just be too much for the browser. Finally, I have to disabuse you of another notion, and that is that resolution tells us something interesting. It does not. Because resolution turns out to be quite different than I expected. This all works in almost all browsers, right? We have a JavaScript property device pixel ratio, and we have CSS media queries min device pixel ratio. It's meant for all WebKit-based browsers, and resolution, which is meant for all other browsers. Chrome is the only one to support both these. Eventually, resolution is going to win out, but for now, you still need this for your WebKit-based browsers. Safari, the old Android WebKit, BlackBerry, many minor browsers. But this is just a minor browser incompatibility problem that we can solve. The problem is, what does this actually mean? What is a device pixel ratio? What are we measuring if we say 192 dpi? It turns out, again in all browsers I tested, that device pixel ratio is the ratio between the screen size in device pixels and the ideal viewport. That may seem strange at first, but it does kind of make sense, especially in the context of responsive images. Because originally Safari invented device pixel ratio to allow web developers to distinguish between retina and non-retina screens. That was the whole point of device pixel ratio. So again, device pixel ratio is the ratio between the screen size in device pixels and the ideal viewport size. So, for instance, on the old iPhone 3G, it has 320 device pixels. The ideal viewport is also 320, so device pixel ratio equals 1. Right? The iPhone 4S with the retina screen, 640 device pixels, still 320 in the ideal viewport, so device pixel ratio equals 2. You knew this. Samsung Galaxy Pocket, which is a fairly old, fairly bad Android phone. Incidentally, if you're serious about mobile testing, buy a fairly bad, fairly old Android phone. Preferably with Android 2, because some of your consumers will still be on that phone. And you will see how horribly wrong you can go with mobile sites. The Android WebKit 2 browser, which is the default browser for all Android phones, is not very good. It's being compared to IE6, and that has a kernel of truth in it. So you won't be happy when you're testing it. I mean, you will be profoundly unhappy when you have to test an Android 2 phones, but sometimes it's really necessary. So anyway, this is a tiny device. It has only 240 device pixels, but the ideal viewport is still 320, which gives us a device pixel ratio of 0.75. Incidentally, this is the default Android WebKit browser. I also run Opera on the same device, and it actually has an ideal viewport of 240 and not 320, which gives us a device pixel ratio of 1. Browsers can take different decisions even on the same device. And I kind of tend to side with Opera here, Because the screen is just too narrow for an ideal viewport width of 320. Why did they choose 320 regardless? Because iPhone. That's a recurrent theme in this whole thing. We web developers have paid far too much attention to the iPhone in past years and far too little attention to other browsers. Which means that other browsers, especially the smaller ones, in order to survive, have to mimic exactly what the iPhone does, even if it doesn't make sense. To me, this ideal viewport size does not make sense. I think Opera is right in saying, okay, it's 240 device pixels, and it's really a tiny device, so let's make the ideal viewport 240 as well. But in any case, this is what the Samsung Galaxy Pocket default browser does. Finally, the BlackBerry Z10, which we already saw, it has 768 device pixels, ideal viewport of 342, which gives us this device pixel ratio. Again, this is weird, but it's not wrong. It's simply a mathematical calculation. I mean, the device pixels are what they are. The ideal viewport sounds a bit weird, but actually makes sense on the device. And if you divide them, you just get this, and it's okay. It's how stuff works on the BlackBerry Z10. We have reached the end of this first presentation. Oh yeah, one plug. I'm writing a book. And you're all required to buy it, or I will become very angry with you. Besides, I need the money. So, it's called the Mobile Web Handbook. It has a chapter devoted entirely to what I told in this presentation, plus a few more interesting facts. For instance, minimum and maximum zooming. Oh, yeah, I can talk about that. I can talk about that today. How much can you zoom in and zoom out on a device? It turns out it's a factor 5, except on Android WebKit, where it's a factor 4. And a factor 5 here means that you can go from zoom level 20% to zoom level 500%, where 100% is again exactly equal to the ideal viewport. If you set the meta viewport, there's a minimum scale and maximum scale. And it turns out that if you set those, you can zoom in or out by a factor of 10, but not larger, so 10% to 1,000%. Except again in Android WebKit, which uses factor 4, 25% to 400%. I don't know why Android WebKit is different than it is. These kind of facts are also in the book. It's, I have been writing this book since October, so I'm currently heavily focused on everything that's in the book, and I tend to forget the stuff that's not in the book. For instance, there's nothing about responsive images in the book. Well, there's the story about the resolution, but that's about it. So I haven't followed the responsive images discussion over the past few months. And there is nothing about things like add cache in the book, so I haven't followed the add cache discussion either in the past months. But it contains pretty much what you want to know about the mobile web when you're an accomplished web developer used to desktop and you want to make the step to mobile. Because really I found that mobile web development is not that different from desktop web development, except in 3 respects. First, the viewport, we saw that already. Secondly, touch events or pointer events, which are similar to mouse events but not the same. And thirdly, in the number of browsers, because there's an extreme amount of browsers in the mobile sphere. And I'll talk a bit more about browsers later on. Anyway, buy this book. This is the end of this presentation. Are there any questions so far about the whole viewport story? Do you understand it? I mean, have I expanded your understanding of what mobile browsers actually do? I hope that's the case.
Is there a relationship between the visual viewport and the ideal viewport? That's what confusing you're describing on the Windows phone that the ideal can be 320 or 364. If one of those is being used, how does that affect the visual?
If one of those is there a relation between the visual and the ideal viewport? It depends. First of all, there are many devices. There appears to be a relation on many devices, but there isn't actually one. Because the visual viewport changes when you zoom. Right? If I zoom into 200%, The visual viewport will be half the original size. And because the whole ideal viewport thing started out with the old iPhone having 320 device pixels and an ideal viewport of 320, many people tend to equate those two, but it's not necessarily the case. I mean, if you use width equals device width, initial scale 1, then you set the width layer viewport to the ideal viewport, and that means that at that point in time, your visual viewport is identical to your ideal viewport, right? On the iPhone 320 by 480, you set width equals device width, it becomes 320 by 480. Now both the visual viewport and the ideal viewport are 320 by 480. However, when you zoom in or out, that equivalency is lost. So the visual viewport, it's best to see the visual viewport as just the stuff you see and as being highly dependent on zoom.
So if you use a meta tag only in your layout before you set the viewport, that would also be the visual viewport?
At start, yes, absolutely. It always, because the zoom level is 100%, unless you specify anything else. So yes, initially it will definitely be the case. This is a bit complicated. Don't get too hung up on the visual viewport. I mean, as I said before, it's mostly important for precision fixed. By the way, I have to take a note to talk about precision fixed. But other than that, for a long time I was thinking that the web could move to zoom-based layouts. That is, a newspaper site would be an excellent example. You see a website, and it has a section, I don't know, domestic news, farm news, sport news, whatever. You see 4 sections of those, and you see the headline really big, but the articles themselves are really small, so you have to zoom in, or ideally double tap zoom in order to read the article. And then you can set the minor articles in such a section to leave a smaller font size, so that you have to zoom in more and more to see the little articles, and zoom out back when you want to navigate the entire newspaper. I thought about this for years, and it doesn't really seem to happen. Maybe it will later on. I still think it's an interesting idea, but you need a good use case. In any case, if you do something like that, then the visual viewport width becomes tremendously important, because you have to keep track of the user zoom level. If for any reason you have to keep track of how the user is zooming, yes, then the visual viewport is really important. But in general, we don't do that. In general, we say, okay, we make sure that the layout viewport has the perfect size for the device, and the rest we kind of leave up to the user. By the way, about zooming, please, please, please never disable zooming. It's evil. I don't mean a bad idea. I don't mean stupid. I mean evil. A friend of mine is a doctor. And one day she was working at the top of the hospital she works in, and she was urgently paged. You know, with an old-fashioned pager that she has to keep around. I don't know why they didn't send her a text message, but they didn't. She was paged. She had to come all the way downstairs because there was a patient that urgently needed resuscitation. He had a heart attack or something. So she walks to the elevator, goes down 10 floors, and walks to the patient, and she knows that it's going to take a little time, so she decides to quickly look up the exact protocol for this kind of situation, which is in an iPhone app she had recently purchased. Takes an iPhone, searches while waiting for the lift, goes into the elevator, and then she sees the diagram, but it's slightly too small, so she can't quite read it. She can't zoom in on it. A patient's life dependent on this slide. I mean, in the end, she already knew what to do. She just wants to figure it out a lot of times. But in theory, you can have a situation where a human life depends on a doctor being able to zoom. So please, 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 never disable zoom. If you're using proper responsive design and the user still has to zoom in on something, it's your fault, not the user's fault. So don't punish the user. I'll step off my soapbox now, but that was a point I wanted to make. Are there any more questions about viewport related stuff? I mean, you can also ask later on. I mean, we still have plenty of time. Not right now? Okay. I'm going to get another glass of water.